All right, good afternoon, folks. It is 12:30. We're going to try and get started here. There are a few people I expect to still show up. There's one of them right there. Zane. The heater's a little loud, so I don't know if that's messing up what you can hear or not. It shouldn't be too bad. So what we're going to do today is we're going to go over some basics on the bandsaw. I got more people coming in. And then we will review real quick what's on the miter saw quiz, and you can take the quiz, okay? So we're gonna start with the bandsaw. And the bandsaw is one of those pieces of equipment in the shop that is pretty common. A lot of people have these. People even have these at home. It's one of those common machines. There are a couple of things about the machine that people tend to think are accurate, but they're not really. For example, bandsaws are considered to be incredibly safe when, in all honesty, I've probably seen more minor accidents on the bandsaw than any other machine in the shop, if for no other reason than complacency, because people think they're fairly safe. They are safe machines when treated properly. A lot of people also think they're very, very easy to use. While in certain senses they are, they can be very difficult to master or use well. So the main purpose of the bandsaw is to cut curves and shapes. They are not in any way intended to cut straight lines. Where we cut straight lines are on the table saw and the miter saw. That's where we get accurate, straight, flat cuts, okay? Bandsaws are not intended to do that. They're supposed to be used for shapes and curves, okay? So if you can keep that in mind, you're ahead of the game already. Okay, so let's go over a little bit of the basics on the bandsaw. So what we have here, we have two 14-inch bandsaws sitting here. You can't see that one. It's an old gray monster over there. We've got another one behind it that we use just for the guitar class. Then we've got a resaw bandsaw, a large 131-inch bandsaw over there. Well, the blade's 131 inches. The bandsaw is made up of a table, an upper wheel, and a lower wheel. This is designated as a 14-inch bandsaw basically because of the diameter of the wheels. The lower wheel on these is the drive wheel. That's what the motor is attached to. The upper wheel can raise and lower. It lowers to remove a blade. Once a new blade's put on it, it raises up to tension the blade, and it can also be angled to keep the blade tracking properly in the center of the wheel, okay? So that's the basic guts on the inside. The blade itself is an interesting little animal. This is one of the blades from the 14-inch bandsaw. It's actually 94.5 inches long. The way these blades are made is there's a giant spool of this material, and they cut it whatever length they need to, in this case 94.5 inches long. And then they weld it or braze it at the joint and grind it flush and flat. The teeth on the bandsaw are offset. What that means is every other tooth is bent in the opposite direction. One's to the left, one's to the right, next one's to the left, next one's to the right. Okay. The teeth should be oriented in a downward position when they're mounted in the machine. Since it's going to rotate this way, with the teeth pointing downwards, it actually tends to hold the material down to the table as it's making a cut, okay? As opposed to the teeth were pointing upwards and it was going this way and pick the wood off the material, off the table. So bandsaw blades can be purchased in a lot of different ways, but the main difference that you would be concerned about with bandsaw blades, here's two examples of a bandsaw blade. One on my left hand here is 1/8 of an inch wide. In other words, this distance here. The one on my right hand is 1/2 of an inch wide. This here. The width controls the radius of cut that you can make. In other words, the skinnier the blade, the tighter turns you can make. The wider the blade, you can't make nearly as tight of a turn, okay? So on these two bandsaws right here, we usually keep a fairly small blade. On the other one, for the guitar class, we generally keep a wider blade because we're trying to cut a little bit straighter. We're not really cutting a lot of curves on that machine. So, basic safety on the bandsaw, okay? First and foremost, the number one thing you have to remember about the bandsaw is you never put your hands in the path of the blade. It's either to the left of the blade and the right of the blade, or both on one side or the other. Or if you're finishing a cut, you can actually pull it from the back side. never place your hand or fingers in the path of the blade. If all of a sudden that board tends to get soft and it speeds up as you're feeding into it, you can take your thumb off, take your finger off, something like that. That's number one, hands and fingers out of the path of the blade. Number two, as you're cutting, you'll notice somebody's coming in. As you're cutting, what happens oftentimes is you put little pieces that will get caught next to the blade or sit next to the blade or basically just be in your way as you're cutting. I didn't want to do it. So here's the problem. If you have a little piece like this, let me zoom this in so you can see it. Okay, if you have a little piece sitting here next to the blade, your first thought for a lot of people is to just take your finger and flick it out of the way or grab it. Really, really bad idea. What usually happens, and this is where I see more injuries on advanced than anything else, is when somebody goes to flick a piece out from next to the blade to get out of the way, they end up flicking their finger right into the blade, okay? And that's gonna take your fingernail and part of your finger off faster than you can pull it away. So as is with every other machine in this shop, you never want to try and remove scrap material away from the blade while the blade is still moving. In other words, turn the machine off, let the blade come to a stop before you get the little scrap pieces out of the way. Same thing goes with the table saw, the miter saw, the router table, any one of these machines in here that can have scraps sitting next to the blade. So that's the basic safety practices on bandsaw. Parts of a bandsaw, other than the two wheels, a very important part is this little assembly right here at the bottom, okay? This can be raised and lowered. There's a lock knob on the back of the machine, back up here. This tight holds this rod in place, and that can raise or lower it. So bandsaw blades are very flexible. Okay, when you're in the middle of a cut, what can happen is that blade, look at that thing can bend 90 degrees. Okay, it flexes a lot. Okay, so what we have here is a system right here and the same little assembly just below the table itself called the foot of the bandsaw. And what this is made up of is there's two little blocks that are held in place by these two thumb screws. Okay, these two little blocks are adjusted so that they're just barely touching either side of the blade right behind the teeth. Okay, those two blocks will help keep the blade from twisting as much. There's also a bearing right here called a thrust bearing. This bearing is set up so that it is just barely behind, about the thickness of a dollar, behind the blade. When you first turn the machine on, that bearing should not be spinning. Once you feed your material into the blade and you start putting pressure on that blade, it's going to back that blade into the bearing and it'll support the back of the blade. The bearing just spins at the back of the blade. That same assembly exists underneath the table, right inside here through the throat. And the deal is this: if the foot of this machine, if this assembly is up above the material like it's sitting right now, it can twist like crazy. It can move side to side, it can twist, it can push forward and back. So what we usually do, and the way we set this up, is I'll take the tip of my finger, set it under the foot, release this little lock on the back, lower this down so that it rests on my finger on the material. That places the foot of the bandsaw about 1/4 of an inch above the material. That helps control the amount that this blade can twist and deflect left and right. Bandsaws are notorious for deflecting. What I mean by that is, as you're making a cut, the blade will drift left or right. They're very hard to control, okay? It's impossible to follow a line that you draw on your material perfectly. And let me show you what I mean. So whenever you use the bandsaw, you want to have something drawn on your material that you're cutting, something you're following. You don't want to just randomly walk up with a piece of wood and just start randomly cutting on it. You want to be following a line. So I normally wouldn't use felt pin on material, but so you guys can see it. So if I wanted to cut this shape on this piece of material, okay, I have a line there, and I've placed an X here because this is the piece that's going to end up getting thrown away. This is my scrap. This is my keep, the piece I'm going to keep, okay? The reason I do that, I never want to try and cut exactly on the line on the bandsaw. There's two reasons for that. Number one, because of these offset teeth, these teeth where every other one's to the left and right, back and forth, it leaves a really rough cut. It's a rough surface. It's not a finished surface at all. So you have to have some material that you can sand that rough surface off. Second is, like I said, there is no way you're going to be able to follow that line perfectly. You're going to come in, realize you're getting close to the line, you're going to have to back up a little bit, move away from the line. You may be coming in and start to fade away from the line too far. You'll have to back up and come back in and get back to the line, okay? You can't cut right on the line. So when I'm cutting, what I'm doing is rotating the board. I'm going to rotate it around to make these turns. So when I start to make this first turn, I'm cutting just outside the line, and I'm going to rotate the board. I'm not going to force it. I'm going to let the blade do the cutting, and I start to get a little bit away from the line. I'm going to back up a hair, come back in at a little sharper angle, and get back close to the line. Okay? I come in for this other curve, and I'm going to rotate the board to make this turn. Okay? So what I end up having is a board that looks like this, okay? Where you can see my line here, and you can see where I came close to the line, but I didn't touch the line with the blade. I don't want to be all the way out here. That's way too much material to have to sand off to get to the line. But you will have to sand the edge that you cut with the bandsaw after cutting. You're going to have to clean it up. It's a rough surface because of the blades. Okay? Let me see what I'm forgetting here. Okay, you can very easily come in here, and if I'm coming straight into a cut, there's no problem with backing out, coming back in, making multiple cuts like that. That's not a problem at all. But if I get into the middle of the board, something like that, and I've got turns everywhere, and all of a sudden I realize I need to get that board off of the blade. You always want to turn the machine off, let the blade come to a stop, and then try and wiggle the board off the blade. If you try and pull it off while the machine is running, you're going to pull the blade right off the tires, right off the wheels. Okay? So shortcuts and short backing out of it is okay to leave it running. It's not a big deal. But if you're very far into the material, if you make some turns, you want to make sure the machine's turned off before you pull the board off of it. Okay? What am I missing here? Let me think. Let's see. Oh, okay. Since these blades are manufactured by cutting a specific length off of a big spool of blade, that weld, that point where the two ends come together, is considered a weak point, especially with the kind of blades we can afford here. We can't afford the very nice blades that the manufacturing process is a little better. But these welds kind of present a weak point. If you're ever running one of these machines, when you turn it on, you hear a very consistent sound like tick, 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 tick. It'll be consistent with the speed of the bandsaw, and you'll hear it. It's loud enough where you're going to hear it. What that means is that the blade is cracked, okay? If you turn one of these on and you hear that tick, tick, tick sound, shut it off, come get me. The blade needs to be pulled off and replaced because it's going to break. Now, if a blade does break, you're going to hear it. If it comes off the wheels, if it gets pulled off the wheels, you're going to hear it. In fact, just about everybody in the shop's going to hear it. It happens all the time, okay? These blades come off the wheels pretty consistently throughout the course of a week.
And one of the reasons for that is I tend to leave the tension on these blades just a little bit soft as opposed to really tight, because I've noticed over time that the tighter I leave these blades mounted in the machine, the more they break, because students don't seem to have the ability to compensate for how much pressure they're placing on that blade and how hard they're twisting it. Not to mention the fact that these bandsaws pretty much run nearly all day out here in the shop. That's generally not a common scenario with bandsaws, unless that's your main machine in the shop that you use for a specific purpose. Okay, so let's see here. I think that's about it for the bandsaw. If I think of anything else, I will certainly tell you. But what we have now is a situation where we've got this piece here, and we've got this rough surface that was left by the blade, and we've got a situation where we haven't made our cut down to the line the way we want. We want to be right on that black line, not away from it. You can see I've got a little bit of material left before we get to that black line. So I'll show you what we do to get rid of that, okay? I'm gonna move the cart. You guys are gonna kind of walk with me here. Do this without hurting me. So we have a number of ways that you can sand in here. What I mean by sanding is this. Well, I shouldn't say that. The purpose of sanding in a shop is to remove small amounts of material to reach a specific point or a line. Okay. Now, to clarify that a little more, get out of here and go this way. To clarify that, we do not use sanders to flatten or straighten an edge or an end, nor do we use them to bring a piece of material down to finished dimensions. Here's a good example. You go to the miter saw and you cut a board to 12 inches long, okay? You grab that board and you take it over the bench and you measure it again, and you realize it's about 1/8 of an inch too long. You didn't cut it properly. You cut it about 1/8 of an inch too long. So I see students all the time that walk over to one of these sanding machines, generally the edge sander, and try to sand it down to the line to the final length. That is absolutely, unquestionably the wrong thing to do. We cut to final width and length on the table saw and the miter saw. You need to take a little bit off the edge of the board because you ripped it a little too wide on the table saw. You go back to the table saw and rip it to final width. If you go to the miter saw and cut a board a little bit longer than it needed to be, you go back to the miter saw and trim it to final length. You don't go to a sander to get something to final length or width or thickness. The only thing sandpaper is intended to do is take off small amounts of material, okay? And it's not going to do it effectively in regards to flat, straight, and square, which is what we're shooting for. Sandpaper in general, whether it's mounted in a machine like this spindle sander that you see in the picture right now, or like our edge sander, or palm sanders, or electric handheld sanders, or just handheld sandpaper folded up in your hand. All it's intended to do is to remove blade marks, burn marks, coarser sandpaper marks, things like that. It's not a dimensional tool, it's a shaping tool, okay? So if you can keep that in mind, you're ahead of the game. So this is our oscillating spindle sander. It can take several different diameters of spindles. You can come off and on, and we can swap the spindle size if we need to, depending on the radius of the curve we're trying to sand. We can also flip these in for in, because most of the time we really only use about this much sandpaper, so that thing can wear. You can see it right now. I flipped this over, so the more worn piece up here is now at the top, and we've got a good piece down here. Down here. The other thing that helps to keep this from wearing out, carry on the sander, is this is an oscillating spindle sander. It moves up and down. That accomplishes a couple things. It keeps this sandpaper from overheating on the edge of the paper,
any machine in here. We want to move our material, especially when we're talking about freehanding like this. We want to move our material against the rotation of the cutter. And sandpaper is a cutter. Okay? It's a cut. So it's moving this way, so I'm going to move my board from right to left. I'm not going to work on the opposite side. Work on the side closest to me. I'm always going to move from right to left. Very similar to table-mounted router. We always move from the right to left on a table-mounted router. Okay? So it doesn't take a lot of pressure. The more pressure you use, the more you're going to damage the material, damage the spindle. Okay? You shouldn't be trying to remove a whole bunch of material here. It should be very small amounts of material. You've got a big wide patch here to get to your mark. You need to go back to the bandsaw and take the majority of it off on the bandsaw. You can come here. Always keep the material moving on it. Don't sit there in one spot and just going to create a big valley. Keep it moving. Keep the fingertips away from the sander itself. Don't ever stand in the air. There's a reason there's a table on here. The material needs to sit flat on the table. Don't put it at an angle. Don't hold it like this. Keep it flat on the table. And take light passes. So you get down to where you want to be. Feel the edge of the material to see if you've got any dents or divots you need to take care of. That can be cleaned up, real light passes on it, and you'll end up taking it down to your pencil line. Okay, so that's how we get down to the pencil line, and that's how we get rid of the bandsaw mark. All right, so that's the basics of the bandsaw and how to clean up after your bandsaw marks. All right. So what we're going to do with the balance of the day, you guys are going to take a quiz. Let me get this thing out of the way a little bit so you can see. All right, and we're going to go over it real quick. Zoom out on this guy. All right, one more. Okay, so here's the quiz you're going to take. The first question, true or false, the table saw is the best choice when cutting two lengths. That is absolutely false. Okay, this is a board I put together. Well, it's a lot of work, as you can tell. Okay, I'm going to move that screen a little bit so I can turn it towards me. Whoops, that's the wrong one. And down. All right, so the question was, the table saw is the best choice when cutting two lengths. Okay, so we cut two lengths on the miter saw with a cross cut. Okay, in other words, our blade is going this way. Okay, cutting across the width of the board, which alters the overall length of the board. Okay, that is a cross cut. That is done on the miter saw. Anytime you see the word cross cut, you should be thinking miter saw. That's it. Okay. As far as you're concerned, in beginning and intermediate woods, chances that you would ever use the table saw in here to make a cross cut are minimal to non-existent. Very rare when we have to use the table saw to do a cross cut. Okay, so that is a cross cut. Where we do our rips, okay, this is a rip cut, cutting along this way. That's done on the table saw. That's when we alter the width of the board. Okay, this edge would be against the fence. We make the cut. That is a rip cut done on the table saw. We don't do cross cuts on the table saw. We make rip cuts on the table saw using the rip fence. Okay, we make cross cuts on the miter saw. Okay, so true or false, the table saw is the best choice when cutting the length. False. The second question, a board must be at least how long to safely cut the length on the miter saw? 6 inches long. That's the minimum length your board can be when you walk up to the miter saw to make a cut on it. Okay, any shorter than that, can't do it. All right. 6 inches is about the length of a dollar bill. Probably the same as a $100 bill as well, but I can't remember the last time I saw a $100 bill. I see dollar bills every once in a while. Okay, so 6 inch minimum length on the miter saw. All right. The next one, the third one, always use a stop block when cross cutting Remember that word, there's that word again, crosscut, more than one board to the same length on the miter saw. Anytime you see the word crosscut on this test, on any test in here, you should instantly be thinking miter saw, because that is where we crosscut, okay? That's where we do it, all right? So if I have to get two similar length boards out of one board, two or more, okay, it is going to be almost, I'm gonna put that same, so it looks good. It's almost it is impossible to take a pencil and a tape measure and a square and measure from this end, measure out 4 inches, make a mark, draw your line, cut it, measure again, make a mark, draw a line, cut it, measure again, make a mark, draw a line, cut it, go and make your cuts. You are not going to get pieces that are all the same length. It's not going to happen. You can't do it on the miter saw. You can't do it on any machine in here unless you use a stop. And a stop is one of those things that you can clamp to a fence or clamp to something that is a specific distance from the blade that allows you to slide the board up to the stop, make a cut. There you go, perfect 8 inches. Okay, slide it up to the stop again, make another cut. There you go, perfect 8 inches. And the bottom line on this, even if it's not a perfect 8 inches, okay, even if these boards, when I'm done with them, are not perfectly 8 inches or 8.5 inches according to the plan, they're the same length. They are exactly the same length. And 9 times out of 10, you're better off with boards that are exactly the same length and maybe a hair off from what it says in the plans than having boards that are all different lengths, okay? So the trick is to get them all exactly the same length. If your plans say you need 12 pieces for a face frame, they're all 13.5 inches long. If you cut 12 pieces that are 13 and 9/16 long, a 1/16 of an inch longer, okay, you're a heck of a lot better off than if you cut 12 pieces that are all different lengths. One of them's a 1/16 of an inch long, one of them's a 1/16 of an inch short, one of them's this, one of them's that, all of them different. That's a heck of a lot worse than having 12 pieces that are all exactly the same, but a 1/16 of an inch off, okay? So it's a matter of consistency is why we use a stop, okay? So the question is, always use a stop block when cross-cutting more than one board of the same length on the miter saw. Fourth question, the edge of your board must be tight against the fence. Is the answer, fence on either side of the blade when cross-cutting on the miter saw, okay? There is a fence on the miter saw. There is a fence on the table saw. There is a fence on the router table. We can add a fence to the bandsaw. There is a fence on the panel saw. There's a fence on the panel router. Looking around here, trying to see. There's fences on a lot of these machines. Whenever there's a fence, you need good, tight contact to the fence with the edge or the surface of the board. Now, that being said, if you think about our order of operations in here, which is the faces, then the edges, then the ends, or it's the same as saying thickness, then width, then length, which is what we do on the miter saw. We do length on the miter saw. If you follow that order of operations specifically, okay, there is no way your board's not going to be tight against the fence on either side of the blade when you crosscut. Because the process that we use for our order of operations is this. First thing we do is the thickness. When we thickness a board, we treat the two faces. Thicknessing is going to create two nice, flat, parallel faces. Those two surfaces, okay? That's our thicknessing process. That's our first step in the order of operations. The second step is the edges or the width of a board, okay? Now, when we treat the edges of the board, when we're done with the width process, we're gonna have two nice, flat, straight, square, parallel edges. So these are nice, perfectly flat and straight. So once we walk away from the table saw after doing faces and edges, once we've gone through those two processes, we've got flat, 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 parallel to this, parallel to this. This is in other words, when we walk up to the miter saw and we put this edge up against the fence, it's going to be flat, straight, and square, and it's going to be tight to the fence on either side of the blade. In other words, if you've done the order of operations in the correct order, there's no way it's not going to be tight to the fence on either side of the blade. If you ever get a kickback on the miter saw, and it will happen at some point, it will happen to somebody, and every single one of us in here will hear it happen, and we'll look over to see what doofus did it. If you get a kickback on the miter saw, you've skipped a step that was necessary prior to cutting to length. You've screwed up the thicknessing process, or you've screwed up the ripping to width process, okay? There's no other way for that to happen, all right? So the question is, the edge of your board must be tight against the blank on either side of the blade, must be tight against the fence, okay? The last question, how many cuts does it take to accurately cut a board to length on the miter saw? It takes 2 cuts. The first cut that you make on the miter saw trims and squares 1 end. In other words, it makes this end square that face, square that face, square that edge, square that edge. Nice and perfect, okay? Nice, like flat, straight, and square. Now that we've got this end flat, straight, and square, we can measure from this end. Come out here and make our mark at our final length, make that cut. That trims our second end. Every single surface on this board has to be treated one way or another. Okay, we can't leave any surface on this board untouched. So it takes, since we have 2 ends, it takes 2 cuts to cut a board length. First is the trimming and squaring cut. Second one cuts it to final length at the other end. Okay, so that's the 5 questions on the miter saw quiz. Now, let me show you your resources for this quiz. All right. So I'm going to share. Oh, we got Vince came in. I don't know when. Yeah, he came in way late. Sorry, Charlie. Didn't see him. All right. So here are your resources for this quiz. Okay. Share the screen here. I'm going to go back to. All right. So here's your home page right here. For some reason, I don't have student view over here anymore. I don't understand why, so I can't show you what it'd be normally. This is my view, not the one you'd normally see. Here's our home page. You go to modules, go to today, right? Here's Wednesday. Here's the miter saw quiz. That should be indented. Okay. Here's the miter saw quiz. When you click on this, there's going to be an explanation and a link. All right, let's take a look at this. Today's quiz covers the safe operation of the miter saw. Below, you will find a link to a copy of the Woodshop Safety Test answer sheet. That's this, Woodshop Safety Test answer key, okay? This link will take you to a copy of the safety test with all of the correct answers included. If you find yourself having difficulty with any of the answers on the quiz, simply click on the link and find the question on the safety test that you're having trouble with. The correct answer will be found there. All of the questions on the quiz are taken directly from the safety test. Nothing has been changed. So if we click on this link, it takes us to the 50-question safety test. Every one of the questions on this miter saw quiz was taken directly from this test. For example, here's the first question I read to you. True or false? The table saw is the best choice when cutting to length. Here is the correct answer. The next one, it's right here. A board must be at least how long to safely cut to length on the miter saw? The correct answer is 6 inches. Okay, you can just put 6 there, doesn't matter. You're just gonna type it anyway. Okay, the next question. So I can find it here. Here it is. Always use a stop block when cross-cutting more than one board of the same length on the, and one of the answer choices will be miter saw, okay? The next question. The edge of your board must be tight against the fence on either side of the blade when performing cross-cutting operations on the miter saw. And then the last one, how many cuts does it take to accurately cut a board length on the miter saw? 2. So if you're having difficulty with any of the questions on the quiz, that's where you find your answers, okay? All right, so that's going to be it for today. I will stay here until the end of class, okay? Go ahead and take the quiz. When you're done with the quiz, you can sign out. You're good to go. Have a great night. We'll see you guys tomorrow, okay? So that's it. Take care of yourselves. Bye-bye, folks. I'll stay here until the end.